Yes, so this research is about a new digital design tool that is not focused only on daylight performance, but we believe that it can integrate daylight performance parameters in an innovative way during the early stage design development. So first, I will try to explain what this new tool does, and then we will see how it relates to the daylight building performance. So the design process, for architects at least, always starts with a client. And this client has certain ideas and wishes about what he wants. And then after a very lengthy process that involves sketches, good sketches and bad sketches, models, complicated models, client meetings that are failed and are very frustrating, more models, late nights with pizza deliveries, renderings. After some point, you reach the construction documents, then you pick the finishing materials, then you start construction, everyone is happy. It can take anything from 2 to 12 years, and then you end up with a finished building, which you can then photograph and publish in architectural magazines. Now, of course, the magazines are only for architects. The client is really interested about using the new space that he has paid. So the interesting thing is that we start with the client's decisions and we end up with a space that he can live in. So the client wants a living room and a bedroom and a kitchen, and then he ends up living and sleeping and cooking in these spaces. So in other words, what will happen in the space is really important. Now let's focus on the end result. This image represents the architectural space as it is being experienced by the users. It can be divided into 3 distinct parts. On the left, we have the environment, which is everything outside of the building, the urban context, the sun, the natural, the nature. Then in the middle, we have the physical space, which is the walls and the slabs and the furniture. And on the right, we have the users that are interacting with both the physical elements and with the environment. Now, we as architects can only control the middle part, the physical elements. But our true goal is to find a balance and equilibrium between all 3 elements. Now, this concept is not something new. It has always been in the mind of the designers, how to combine all these 3. The problem is what happens now when everything is into the computational workspace. So basically, as we saw from the design process timeline, most of the process takes part into the screen, into the computer. So computers are excellent in describing geometry, but what about human events and interactions? So the proposed tool tries to investigate if it's possible to introduce the human activity element in computational design software in a way that informs the design process and improves the final building product. In order to do that, the new tool attempts to introduce the human element into the design workflow by creating a new component, the event platform. Now, event platforms are transparent volumetric digital representations of the intended human activity of a certain space. The goal is to complement the geometric building elements that all modeling software have with a novel type of entity that is capable of representing human events and interactions. Now, these components can be parametrically controlled in the following manners. The designer can dynamically control their dimensions, their footprint, and their volume. Moreover, it is possible to assign various event scenarios to each platform. This is achieved by quickly inserting avatars and selecting their activities through pre-established motion capture libraries. Apart from the activities, the designer can also define parametric connections between the platforms. These can be either physical or visual. Physical connections establish how the avatars move from one platform to the other. It's basically the doors and the gateways between them. Oops, sorry. Well, the video reset. So it will play and it will get the same position. So we have the physical connections, which are the gateways between them, and then we have visual connections, which determine how much of the surrounding context is visible to the avatars of each platform, which we will see right next. Everything is done in a plugin into an existing modeling software. So this is what you see now. It's the user interface of this plugin. So this is the physical connections between the two platforms. And then we can also define the visual connections, which is the opacity of each border of each platform. So how much is visible from each border of each platform to the outside. So using these platforms, the architect can use the plugin and manually create and manipulate a transparent event skeleton of the design building. Additionally, it can automatically generate several configurations of the platforms based on the desired connections and the available plot area. Then, once we have this skeleton, the designer can dynamically link these skeletons with parametric geometric panels. By assigning different geometric panels to specific borders of the event platforms, the embedded characteristics of the platforms, type of openings, materiality, etc., are informed by the visual and physical connections of the platforms in order to achieve the final building geometry. In essence, we have a geometric scheme that has to conform and wrap around the event skeleton of the building. However, this process is not linear. The designer has the option to evaluate the model through visual and data feedback that the plugin provides. The visual feedback takes advantage of the human events that take place inside the platforms. The plugin automatically positions multiple cameras around the avatars using cinematic conventions. It then evaluates all the cameras by taking out the bad angles and the dark scenes and produces a 15-second animation matrix with the 9 most suitable cameras. At the same time, it's possible to evaluate these animations as daylight performance diagrams. This functionality of the tool has 2 specific advantages. First, the architect can have an indication of the daylight performance at a very early stage in the design process. Usually, this information comes from specialists at a later stage from the building physics specialist, and by then, it's quite late to really change the design. The second advantage is that this feedback is not uniform for all the building, but it's more focused on the areas of interest, the areas that the architect thinks there is most action and most interaction with the humans inside. So you can see that in the top part, of course, the tool functions also from the inside and also from the outside. From the outside, daylight performance is not so important, but from the inside, we can have a quick and dirty view of what is going on about the lighting levels. And this is very easy to do with our current rendering software because they're already calculating it for rendering purposes and taking this not scientific but quick and dirty information and applying it in this level of the early design. I think it's useful to the architect to guide his design before even it settles. Now, apart from the visual feedback, we have the data feedback, which consists of comparative diagrams that are based on the event platforms. So on the left part, you can see this is all the spaces that we have in the event platforms. Then here we have area of each platform. Then in this column, we have the average lighting level of every platform, which is useful information to have. And then the next 2 columns depend mainly on the human events and what happens inside the platforms. So basically, we take the point of view camera of all the avatars, and we calculate what is visible in the frame during the animation, during the action. So with green here, I don't know if it's visible, with green, you can see how much of the outside environment is visible during the event of every avatar. And you can see here, this is the frame, the point of view frame, and the green is the outside, so it calculates how much of the percentage is the outside. And you can see that some spaces have a good relationship with the outside and some not so good. Then the blue is another similar parameter, which is how much of the other avatars are visible. So when I'm moving into space, how many other people am I able to see? This is also another parameter. And the third parameter that we have here is basically how spacious the space feels. So it measures every avatar, how much space in front of him does he have when he's walking through the space. So these are three parameters that we are currently measuring. A fourth one would be to apply a similar tactic of how much lighting levels are visible from the point of view of its character. So instead of having the average lighting that we have here, to have a more event-based lighting levels performance, which would be another step that we will try to implement. So based on this feedback mechanism, the designer is able to make adjustments to the model and improve the project. So it's not a linear process. We get these diagrams, we get the animations, and we go back and forth by changing the design and improving it. That's the concept. The ultimate goal of the plugin is to allow the designer to make bidirectional connections between human events and geometric components. Now, summarizing, we can say that the proposed tool allows us to insert human activity representations into modeling software and to create event platform configurations that can be parametrically linked with the geometry of the building. At the same time, different configurations of the event platforms can be generated automatically, while the designer has constant visual feedback through the animation matrices and data feedback through the data diagrams. As you can see here, the tool is responsible for the 7 images on the perimeter, but the actual design happens in the complex web of connections in the middle. And this network of connections depends entirely on the architect himself. The intention of the proposed tool is to remind designers that architecture is not about empty spaces. It is about spaces full of people interacting with each other. And our digital design tools should somehow reflect that. Thank you for your attention.